guys, welcome to Layla Teaches. Today we'll speak about lipids, triacylglycerols and phospholipids. So when we speak about lipids, like triacylglycerols, we have glycerol, which is a very important compound. You need to know the structure very well. It is the backbone of triacylglycerols or lipids in general. So this is what glycerol looks like. It is 1, 2, 3 propane triol. If you join it with one fatty acid, it is monoacylglycerol with 2 fatty acids, diacylglycerol with 3 fatty acids, triacylglycerol. And this is what the final compound will look like. So you have an ester bond. So the glycerol is an alcohol and the fatty acid obviously is an acid. So you get an ester bond. You can say it is esterification. For example, if I ask you to draw a triacylglycerol with formic acid, acetic acid, and propanoic acid. So again, first keep the structure of glycerol in mind. You draw that one. Then you draw the 3 acids. So formic acid, carbon 1, acetic acid, carbon 2, and propanoic acid, carbon 3. You just have to remove water molecules. Because there are 3 alcohols and 3 acids, we remove 3 molecules of water. And what do we get? We get a triacylglycerol with 3 ester bonds. It might look complex, but it is just bigger structures. The mechanism is the same, like a simple carboxylic acid and a simple alcohol. The same way that you formed it, you can break it. So hydrolysis of TAG will give you a glycerol molecule and 3 fatty acids. And you have to use up 3 molecules of water to break this bond. So it is a reversible reaction. Alright, another type of reaction is saponification. So when you have a triacylglycerol and you react it with let's say a base like sodium hydroxide, which is a very strong base, you're going to get glycerol molecule on its own, and then you're going to get 3 as the 3 fatty acids, you will get 3 carboxylate salts. So the OH of the acid will get, the H will get replaced with Na. So you get O minus Na plus with 3 water molecules. And obviously because we have 3 fatty acids, we're going to have 3 molecules of the base as well. So the first one, we can get a salt with formic acid, and then formate, and then acetate, and then propionate. When we speak about phospholipids, you can have 2 types, one with glycerol as the backbone and one with sphingosine as the backbone. Sphingosine is an 18 carbon molecule, and you need to know the structure. It is quite important. So the last carbon is like glycerol. The second carbon, instead of hydroxyl group, it has an amine group. The third carbon is also like glycerol, but instead of having H2, it has only 1 H because it needs to attach to another carbon. You have a double bond in sphingosine. Then you have to add the 12 carbons and then 1 carbon. Now when you count it, see 1 plus 12, 13, plus 2, 15, plus 3, 18. So see 18. And this is the backbone of most phospholipids. Now I will show you what the final ester product will look like when you use sphingosine. We're only interested in where the ester bond will form. So that is what I will show you. So in the first and the third carbon, we are going to do normal esterification. But in the second carbon, we're going to do a peptide bond because we have amine group and then the carboxylic acid of a fatty acid. So the most common alcohols are mainly used in phospholipids are ethanolamine, serine, and choline. And you also have acetylcholine, which is a neurotransmitter. But remember these three compounds because they are mainly the ones that attach to the first carbon in sphingosine. Instead of acids, you mainly have these three. So this is what the bond will look like. So the first carbon will have a normal acid. The second carbon will also have a normal acid. The third one, because it's a phospholipid, it will first form an ester bond with a phosphate, which is phosphatidic acid, and only then that phosphate will form an ester bond with the alcohol. For example, in this case, choline. So phosphatidyl choline, it is important to include the phosphate. Okay, now moving on to the homework for today. Question number 1 is show me the hydrolysis of ester, a triacyl glycerol containing acetic acid, butyric acid or butanoic acid, and phosphatidic acid. The second one is draw phospholipid, so knowing which one would be the backbone, with 2 acetic acid molecules and ethanol amine. Do not forget the phosphate because we're talking about phospholipids. Alright guys, that is it for this video. I will see you in the next one. Take care. Bye.